Good day to everyone who's watching. In our lesson of algebra today, we are going to talk about changing the subject of the formula. This is just the process of making one unknown to be on the left hand side alone, and then the others you put them on the right hand side. For example, the y here is the subject of that formula. It is one side of the equation, and then the rest, the m, the x, and the c, they are on the right hand side. V is also the subject of that formula there. Then the rest of the parameters r and h, they are on the other side. Then when you look at this third one here, x is not the subject of the formula, although you are seeing it alone on the left hand side. Why isn't it the subject of the formula? Is that when you look at the right hand side of the equation, you can see that there is another unknown x. So both of them, they are like terms. You need to first correct, then thereafter you simplify and you make x to be the subject of the formula, that is leaving it on the left hand side of the equation alone. Steps we take to do these things here, they are just the reverse operations. For example, if I had c is equal to y minus mx and I want to make y the subject, you can see that this other part which is attached to y is being subtracted on that side. So the reverse operation of subtraction is the addition. So I add mx both sides. Mx plus c is equal to y minus mx, then plus mx, such that this mx and that one there, they can cancel out, and then you have y to be equal to mx plus a c. Then rearranging, this is going to be y is equal to mx plus a c. So we just do reverse operations. You can have m squared is equal to f times e plus b all over k. So to make m the subject, here we are having m squared, but we only want to make m the subject. When you look at the m here, it is still attached to by a square. So to kill that square or to remove that square, we apply the square root both sides, such that the root this side can cancel out the square on m, and finally you have m as the square root of f times e plus b all over the k. So we just do reverse operations. So my example 1, given that y is equal to mx plus c, make x the subject of the formula. The equation is y is equal to mx plus a c. I'm going to look at all ways of making this x the subject of the formula there, or the equation. Now I'm going to first take c or eliminate c from the other side, because it is still attached to the whole of that is having the x with an operation of addition. So you subtract both sides by c. So this is going to be equal to y minus c is equal to mx. You can see now the other side, what is stopping me from making x the subject of the formula is the m and m is having an operation of a multiplication with the x there. So what I do, I'm going to divide both sides by m such that the m here cancels there to have x along that side to be equal to y minus c all over m. So just rearranging, beginning with the x, this is going to be equal to y minus c divided by m. Example 2, make k the subject of the equation. M plus 4y is equal to k minus the 3n divided by c. So this one here is just simple because the k on the right hand side there, it is being divided by a 1 and it has no coefficient here, or it has a coefficient of 1. So we are going to just get the minus 3n and we take it the other side. If I have the left hand side equal to the right hand side, that means that also the right hand side is equal to the left hand side. So I can rewrite just this equation as k minus 3n all over c is equal to m plus 4y. Now I've made my right hand side to be the left hand side, then the left hand side to be the right hand side there. So I've said I'm going to get the whole of this and I transfer it the other side. So this is going to be k is equal to m plus 4y then plus 3n all over a c. It has been a negative, now it is a positive. So even if I don't simplify any further, because I've not been told to simplify, I've been just told to make k the subject of the equation there. Example 3, if v is equal to w times the root of a squared minus x squared, make a the subject of the equation. So my equation is that when I look at the right hand side, I'm having the w times the square root of whatever is inside there, which is a squared minus x squared. So what I'm going to do first is to first eliminate the w on the right hand side. So since it is multiplying, I'm going to divide it by both sides. Then now it cancels out on the right hand side. So I'm having v all over w is equal to the square root of a squared minus x squared. So now I'm going to look at a way of eliminating the root here, because now it's the root that is stopping me from making a squared the subject. So what kills the square root is squaring both sides. Remember the root, when you looked at the indices, we said it has, the root is the same as power a half. If I have root of x, this is the same as x power a half. Now, if I want to kill the power a half, I need to square. When I square, that and that cancels out. So as I can have x to power 1 there. Now, I'm going to square both sides of my equation there. Squaring this side and also squaring that side. The square here is going to cancel the square root, then I'll be having only a squared minus x squared is equal to v all over w squared. Now what is stopping me from making my a the subject is the minus x squared. So I'm going to get this minus x squared, I bring it this other side of the equation. So this is v all over w squared then plus x squared is equal to my a squared. Then my a is still having a square. So what I do to kill that square is taking the square root both sides. So I take the root on the left hand side, b all over w squared plus x squared is equal to root of a squared. So this root is going to cancel out the square. Then finally I'll be having a as equal to the square root of v all over w squared then plus x squared. Then some students like King, they can go on to say that this one here, the a is equal to v all over w then plus x. For them thinking that the square root killed the square which was here and also killed the square which was there. That one there is wrong. Mathematics, please. Whatever is inside under the square root is still being managed by the operation of addition. So you need to first add those two things there, then you take the square root of everything which is under the root. My example 4, given a is equal to p into brackets power n, make n the subject of the formula. So when you look at this bracket that is having the power n, it is still attached onto the multiplication of p. So first removing p by dividing both sides by the p. So a divided by p is equal to p in divided by p into 1 plus r all over 100 then into the n there. So at this moment I'm having the a all over p is equal to 1 plus r all over 100 into the n. Now I'm going to look at ways of removing this n from the power, and I place it in the numerator. When you go back to our work of logarithms, you used to see how we used to remove these powers from the numerators to the denominators. There's that law which had log of a power b base c, that this one here, the b can move from the power and comes to the numerator to be b times log of a base what? Base c. So here we are going to introduce that concept there. Now I'm going to apply log base 10 both sides. So after applying log base 10 both sides, now this n on the next step is going to somersault up to there. So this is going to be n times log of 1 plus r all over 100 base 10, then log of a all over p base 10 there. So now my n is in the numerator. Now I can divide both sides by the other part, which is multiplying by n. Then the whole of that is going to divide the whole of that, and then I'll be having n on one side So the n is going to be equal to log of a all over p divided by log of 1 plus r all over 100. Example 5, given that n is equal to that one there, make y the subject of the equation. So our equation is that we have y in the numerator and y in the denominator. First step is always to eliminate the numerators. This left hand side, the n is all over 1, so we are going to cross multiply. That's going to be n into 3y plus a 2 is equal to 1 into the y minus the 3. 1 times anything is that anything, so that side we shall be having 2y minus 3. Then this side, when you open the bracket, n is going to multiply whatever is inside there, so that is going to be 3ny then plus 2n. So now here I'm going to collect the like terms, those having y, because my aim is to make y the subject of the formula there. So when I take this one, the other side, then I bring that one this side here, I'm having 3ny then minus 2y is equal to the negative 3, then minus the 2n. I'm going now to factorize out y because it is a factor in these two terms here. So when I pull it out, here I'll be left with only with the 3n minus the 2 is equal to negative 3 minus 2n. So now this bracket is multiplying y, then I'm going to divide it both sides. Divide by the 3n minus 2 is equal to negative 3 minus 2n divided by 3n minus 2. So this and that, they cancel out because they are the same. Finally get y is equal to negative 3 minus 2n all over 3n minus 2. Some other person can get this y to be equal to positive 3 plus 2n, then divide by 2 minus 3n. For that person who took the 3n y the other side, then brought the minus 3 this side, these two answers are the same. So this example 5 is just like this equation that I first wrote in the introduction of changing the subject of the formula. So you see that the x and the x, they are both at different sides of the equation. So you must first simplify, bring them one side, then do the factorization, and then divide both sides by that bracket. That will be multiplying the factored out x. So doing the cross multiplication, the a is going to multiply the x to be equal to b plus cx. Taking cx this other side of the equation, it becomes a minus. Then the other one, you are left there with only b. X is a factor, so when you factorize it, that we shall be having a here, and then there we shall be having a minus c to be equal to a b. Then you divide both sides by a minus a c, even this side by a minus a c. such that you get the x to be equal to the b all over the a minus the c. Here you can see that there is only x in this whole equation. The x is only one side of the equation. So we have our example there, given that q is equal to I squared times r times t, make I the subject, hence evaluate I for q is equal to 1000, t is equal to 20, and r is equal to 2 there. Now this example has two questions in one. The first one is to make I the subject. Q is equal to I squared times r times t. These two are multiplying the I squared, so I first divide them both sides. Then I'll be having q all over rt is equal to the I squared. Then from there, to make I the subject alone, is to eliminate the square there by applying the square root both sides. So when I take the root, the square here is going to cancel. Then I'll be having I alone to be equal to the square root of q all over r times the t. Then finally, I can state that the I is equal to the square root of q all over r times the t. So this up to there, that is answering the first part of the question, making I the subject. Now, the second equation, they're telling me to use what I've got there to evaluate I by substituting q as 1000, t as 20, then r as a 2. So for q is equal to 1000, t is equal to 20, r is equal to 2, I is going to be equal to square root of this one there, 1000 divided by t, which is 20, times r, which is a 2. So when you divide 1000 divided by the 20 times 2, that one is going to be 25. Then I still have the root there. Therefore, the value of I is going to be plus or minus 5 there.